Hello everyone, and let's solve quickly a question from Leetcode. So it says delete the nodes from the linked list present in an array. Now the question is quite simple. So we have provided with a linked list as shown within this example. Also we have been provided an array. So whatever elements which we see within an array should not be present in the resultant linked list, and we need to return the existing linked list. That means within the existing linked list, if we find any of the elements of an array, we need to just ignore that. In this case 1 to 3 is present within an array and 4 5 was not, so 4 5 we have returned as a new list. And same as here, 1, and for each one within an array we have ignored it and returned 2's. Same goes with this. If nothing was present, nothing was removed, then we return the same linked list. So keeping that in mind, let's get forward within a code. Code seems pretty simple. The only thing is we need to go ahead and compare multiple times within an array. Shall we avoid that? Yes, we could avoid that. As of now, comparing, checking whether 1 exists within an array, 2 exists within an array, or so on, takes O of array size time complexity, which is not good. So if you are going ahead with a lengthy list, we need to go ahead and check the array each time. So what we'll do is we'll get rid of this by implementing a simple data structure known as set. So we'll have a set of integer which will be set, and I'm using a Java over here, so I'll be using inbuilt method arrays.stream. I'll be streaming nums, and upon this nums I'll be using boxed, and when I'm boxed I'll just collect this method using collectors dot to set. Do not get intimidated. This is just a fancy way to say that hey, I'm having a integer array, just convert this integer array within an integer set. You can use a traditional for loop, that also works fine, but I have did in this way. What I'll need the next, I'll need a pointer, or I'll just say list node pointer, and I'll say it's a dummy node, new list node, and you can assign any value to this like this. It's just a dummy pointer which will say that hey, I'll be pointing to result array, so don't bother about it. List node about an iterator, so that this will iterate and this will generate a new list for us. It would be initially pointing to dummy node because this would be pointing to answer, and we want this iterator to store the answer. Now once we are done with the storing of answer, let's use this source list. Source list is denoted by head. So head, until head is not equal to null, I'm going to iterate this one, and I will be checking that if set dot contains head value. So if set doesn't contain the head value, I'm going to proceed with this then and only then. So how I'll be proceeding? I'll say hey iterator, the next to you would be a new list node which would contain the existing value of this head. Why I'm containing this existing value? Because obviously it's not within the set, and now I have been assigning to iterator. I need to advance the iterator, so itr is equal to itr dot next, and ultimately I'm going to do head is equal to head dot next, because we have done traversing this list and we don't want to enter into the infinite loop. Once that is done, then why don't we go ahead and we return the list result. So as we mentioned that dummy stores the pointer to the resulting list, so I'll go ahead dummy dot next. So far so good. Let's run this code. It seems that our code has been accepted with the sample test cases. Let's submit this one to check for the rest of test cases as well. So yeah, it seems that our test cases has been passed, and the time complexity required for this approach is O of n plus O of m, where n denotes the length of array and m denotes the length of head list, as we are traversing both. So yeah, that's all for this questions. If you wanted to know more about array or linked list kind of questions, click the video on your right, and I'll see you in the next one.